Hello, everyone. My name is Ann Woods. The following is a presentation about IDO, short for Intermediate Data Object. At the end, there will be a short demonstration of it. So where does IDO fit in the process of mining electronic health records? Typically, when an analysis method is taught, a ready-made analysis dataset is provided to practice with it. So that's like the blue and green boxes here. This is where the analysis method is taught, and we're given the input data set to practice with it. However, in real life data analysis, we're not given a ready-made data set. We need to create the data set by considering what information should be included that best represents the problem framework. We also have to present it in a way that the analysis software can understand. This step is called feature engineering, and it is an integral part of real-life data analysis, where we typically have to cycle through all three boxes, and often more than once. Most of the EHRs are stored in a relational databases, such as VA's Corporate Data Warehouse, CDW, or its OMOP version. The data are time-stamped encounter records organized by clinical domains. Programmer writes custom codes to wrangle them into analysis variable under the instruction of the investigator who determines the analysis method. This process is manual, time-consuming, and iterative between the programmer and the investigator. Much has been devoted to method development that affects this box here, while feature engineering over here has not been getting the attention it deserves, even though the quality of the analysis is both a function of the data set and the algorithm. So IDO is about creating a type of analysis variable from EHRs that are commonly used in healthcare. IDO is a framework that comprises of data structure and two functions that interpret it. Together, they simplify the coding for creating analysis variables so that this task can be automated. So what's meta feature selection? Feature selection refers to the selection of a subset of independent variables from the analysis dataset that leads to optimal result from the analysis algorithm. Since IDO can create the analysis dataset by computer scripts, it makes meta feature selection possible. That is, we can optimize the formulation of the features, not just their selection. In this slide, I will explain the concept of how the IDO data structure in the form of a sequence is created from prescription records. A prescription record contains a dispense date, R1 date, and day supply. So R1 date plus day supply minus 1 will give us the date the medication runs out. We call it R2 date. In other words, R1 date and R2 date indicates when the patient was supposed to be on the medication, and this period is represented by all the ones. So here are 3 prescriptions, and there are 3 sets of ones. We build the medication history chronologically, 1 prescription at a time, starting from the first 2 prescriptions. If the second dispense date starts before the end of the last one, we grow the sequence by appending the second one to the end of the last one. And then we move on to the next prescription. We repeat the same process. If it starts before the end of the last one, we append it to the end of the last one, and hence grow the sequence. In the second example, the third prescription here has a dispense date that was after the end of the last one. So instead of appending, it was copied into the last sequence in the same position. And lastly, the period between the 1 segments are zeros, meaning that the patient was not on the medication during these times. In this slide, I will explain how an analysis variable is created from a medication sequence. Suppose we wish to identify patients who were initiated on medication A after at least 100 days of washout. With an IDO sequence structure, it means that we're looking for a segment with at least 180 leading zeros, followed by a 1. Below is the SAS code to do this. Well, first, we'll specify the regular expression for this pattern. Next, we use SAS regular expression function, PRX substring, to search the medication A sequence for the pattern. If found, the function returns the first position number of the matched segment, otherwise it returns a 0. We define a binary analysis variable found, indicating whether the criterion was met. Clearly, this can be generalized to other patterns. User can supply the regular expression directly or parameters describing a pattern. Other analysis variables like a segment relative to the match position, internal pattern of that segment, or their corresponding calendar dates. The dates or the positions can in turn be used to locate values from other sequences and create analysis variable from them. I believe time-varying covariates are particularly useful in analyzing patient medical data in real-life situations. However, creating them from timestamp encounter records is challenging. Typically, when we think about variation from n data points, we think of them as from a single source of variation, like subject to subject variation. However, this is not always the case. 10 measurements can come from 2 subjects, each measured 5 times, or 7 subjects where 3 had 2 measurements and the other 4 had 1. More generally speaking, variance is a function of variance components and the numbers from each component. In the first table, we show measurements taken over time from 2 patients in an experiment. In a control experiment, the treatment is given an outcome measure in a predetermined schedule, like 0, 5, 10 days, so on. So the treatment and outcomes values are obtained at the scheduled time. In real life situation, patients can receive treatments for different conditions, and these treatments can all affect the same measurement. As in the second table, we first need to determine the dates of the outcome measures. Then we need to derive the treatment and possible confounder information relative to the measurement dates. Because the measurements are not taken according to a pre-specified schedule, deriving the time-varying covariate values involves complicated programming. This task, however, is made a lot easier using IDO because information on any given date can be obtained in a straightforward manner using the accompanying time and state functions.